Hello everyone, my name is Gabriel and today I will be showing MetaHub. MetaHub is an open source security tool I started 1 year ago, and its focus is to help us implement a contextual impact-based vulnerability management approach contrary to the severity-based one that most security scanners offer. In cloud environments, this tool is for AWS specifically, where we manage thousands of resources. Severities are not sufficient for managing vulnerabilities. We will always have plenty of them. So where we should start? What is really important for us? That's why the name for this demo is Automating Ownership, Context, and Impact Assessment in Security Findings. MetaHub will help us automate these 3 key stages when analyzing a security finding: ownership, context, and finally, impact. So just briefly about me, I have worked as a security engineer for the last 15 years, focusing on networking, infrastructure, and cloud-related roles. I'm a big supporter of open source and automation, and I love coding. That's why during the last few years I have been contributing to some open source projects that I also use as part of my security arsenal, and creating and maintaining some of my own, which you can find in my GitHub if interested. So let's start with cloud vulnerability management and the tools we use for it. Analyzing all our resources and identifying thousands of possible vulnerabilities manually will be impossible. Automation is key when thinking about vulnerability management. It automates this process for us and helps us with what is really important, that is not the amount of security findings we have, but the time it takes to detect them and fix them. The most common security scanners available in cloud are CSPMs, misconfiguration scanners, and software vulnerability scanners. These scanners are excellent at detecting hundreds of issues that would be impossible to detect manually. And they do it really well. They are fast and they can scan multiple different services. The problem with these scanners in general is that they define the rule set based on standards, meaning that they define generic definitions and generic severities for each finding. They don't provide any type of correlation between these findings, and they don't provide you with context. At the end, this means a lot of manual work to understand the real impact of a finding. This way, we lose a key opportunity: automating alerts or remediations for findings that we are confident enough that could have a real impact in our context. So let's look at what the triaging of a security finding looks like. Here we have 2 security findings. The first one refers to an unrestricted security group, and it was generated by AWS Security Hub. The second one refers to the vulnerable software version being used in an EC2 instance. So what information do we usually have from these tools or any other scanning tool in general? First of all, we have the severity. For this security group unrestricted, we see that Security Hub assigned it critical as the severity. For the software vulnerable version, it's a high severity finding. Then some scanners provide us with a status. We could also get the region and the affected account ID where the resource is running. We will have a title, a description. Probably we will have also some documentation on how to fix this finding. And we will have some information about the resource, like the name, the ID, and probably some other keys on the affected resource, but not much more than that. So what else do we need to understand the impact of these findings on our environment? If this security group is not attached to any other resource, is it still a critical finding for us? Or if the security group is attached to other resources, where is the impact of this finding? Is it in the security group itself, or is it in everything else that the security group is attached with? If for this EC2 instance, if the EC2 instance is not connected to any other resource, is not effectively public, its IAM profile is restricted, is it still a high severity issue for us? When triaging a security finding, we usually go with a 3-step process. First, we need to understand who owns the affected resource, who created, when, and who should I report it to in case someone else needs to fix it. Second, what's the context of the affected resource? What do I know about the resource? What is it doing? How is it associated with other resources? If there are other findings for the same resource. Finally, and only after getting all this information, can we define the real impact for our context. Scanners don't provide enough information to make this analysis, so you must go through a manual process to find it. Doing this manually takes a lot of time, and we lose the ability to automate actions for important issues based on their impact. So let's talk about context. What information is available programmatically that could help us with this process? Tags, if used consistently, are an important way to understand the affected resource. They can provide information about the environment, the system, the owner, and maybe even the type of data that we are storing in those resources. CloudTrail can inform us who created the resource, when, how, from where. If you isolate environments using different AWS accounts, having information about the affected account could provide us a lot of information about its context, like configurations that the resource inherits from the account, or information like the security contacts of that account. Then we have the configuration of each resource that is based on its type, like rules, IPs, endpoints. And lastly, and most importantly, as I see it, is what is the affected resource associated or attached with, like at the network layer, VPCs, subnets, at the security layer, security groups, network ECLs, web application firewalls, at the access layer, like IAM roles or policies, maybe boundaries, and any other resource that could be associated with the affected resource. EBS, autoscaling, maybe a Lambda, other type of resources. What is important about these resources is that they are a resource in itself. So it's important also to understand each of its contexts. So if we have all the contextual information about our affected resources, what can we use from it to define the impact of being affected? Well, that depends on our context, but there are some basic properties that could definitely help us most of the time. The security findings affecting the affected resource are only one part of this calculation. What we could add to it is, for example, the status. If the resource is an EC2 instance, if the EC2 instance is running, or if it's a resource like a volume or a security group, if the resource is attached or not. The exposure. How is the affected resource connected to other networks? Mainly the internet network. The access layer. What can the resource do based on their policies? The encryption layer, like based on their configuration, if the resource is encrypted. What about the data that we are storing in those resources? Is that data encrypted as well? And finally, the environment. Which environment is the resource running in? Is it production? What if you can answer all these questions about your affected resources in an easy way? Well, that was the main objective when I started this tool. The idea was not to reinvent the wheel. There are so many good open source security scanners out there. So how can we still rely on them, but add what is missing to implement a vulnerability management approach based on context? So how MetaHub works? MetaHub first reads your security findings from your scanner. So it can read from AWS Security Hub directly from its API, but it can also read from any other scanner which supports the ASFFF output format. It then connects to the affected resource in the affected account for fetching context. So MetaHub supports multiple account setups, so it can assume roles into every affected account automatically. Each time there is an association, it connects to the associated resource again for more context. We call this process drilling. After that, it calculates the impact conditions: exposure, access, encryption, status, and environment. is it important to understand that the only way to have the correct output for these properties is to understand the affected resource, but also their associations. As an example, for an EC2 instance with a public IP in a public subnet, the instance will be only effectively public if a security group with an open rule is associated. If we are trying to understand if an S3 bucket is public, we need to understand its policy, but we also need to understand the account configuration to know if, for example, there is a public block enabled. MetaHub then calculates an impact scoring for each finding and each affected resource. This scoring is based on all these previous properties that we calculated, but also based on the total amount of security findings and their severities affecting the same resource. Finally, it generates visual and programmatic outputs that you can integrate with your actual systems. So let's see how it works. So for this demo, I have an AWS account with a few resources deployed, and I enable Security Hub in this account. Security Hub will be the source of my security findings for this demo. So I already have some findings in Security Hub. Security Hub is also connected with AWS Inspector in this account. So I can group by product, and we see that I have findings from Security Hub, its own standards, and also from Inspector in the same instance. And I have the MetaHub repository here. MetaHub is a Python program, so you can run MetaHub directly in your CLI using Python. You can also run MetaHub as a Docker container. You can build the container locally, or you can use the container available public in ECR that is provided as part of the tool. You can also run MetaHub as a Lambda function, and you can even then connect that Lambda function with Security Hub that we will see later. So for this demo, I will run MetaHub directly from its source code. So the first step is to clone MetaHub. After cloning MetaHub, I will install the Python virtual environment and all the required dependencies. Module virtual environment installed. So I will source. Now I will install the required dependencies. So that's it. That's what we need to run the application. So let's explore first quickly some of the options available for running MetaHub. You have options for defining the source of your findings. Remember, the first step for MetaHub is to read your findings. So if you are using AWS Security Hub, you have options for defining the role, you have options for defining the profile, the region, the account. And if you prefer to read from another security scanner, you have options for specifying the file generated by those security scanners. Those security scanners need to support the output ASFF format. So if you generate that output, you can then specify that file as input in MetaHub. Then you have options for defining if you want to take actions in your Security Hub findings. If you are reading from Security Hub, you can, for example, update the workflow status of your findings, or you can enrich back those findings with the contextual information that MetaHub will generate. Then you have options for defining which context keys you want to fetch from your affected resources. And you can also apply filters on top of these keys, on top of these configurations. You have also an option for defining a role to assume in the affected accounts. Then you have some options for defining how you want to see the outputs. So in my case, my terminal is already connected with my AWS account, so I don't need to provide any other configuration for MetaHub. I will run the tool without any extra option. So every time you run MetaHub, you will have the options that you are using for that execution. In this case, we see that the input is Security Hub, that is its default input. I have the account ID where I'm connecting, the region that is being read from my environment, the default filters that I'm using for reading from Security Hub. By default, these filters are record state equal active and workflow status equal new. These are the filters that if you use the console, you have as well by default, new and active. MetaHub, the first step is reading the findings from its source. So we found the findings that we have in Security Hub. It starts analyzing finding by finding, and after that, it generates a result. In this case, we have the same amount of findings that we found in Security Hub. We see that these findings are only affecting 35 different resources. We have then some simple statistics and all the outputs. MetaHub generates 7 different outputs, 4 of them are JSON, and then you have an HTML output that we will see later, a CSV and an Excel one. So I will start by exploring the first JSON output. I will open the full one. For exploring this output, I will use the FX tool that let me explore this more easily. So what I have here is the list of affected resources. MetaHub will always group your findings by affected resource. So here I have the list of affected resources affected by the security findings that we are getting from Security Hub. So if I expand one of these affected resources, we will see that the first section is the findings that are affecting this resource. So in this case, this resource is affected by one finding. I can expand here and get more information. Then we have some basic information from the affected resource, and then we start seeing the contextual keys. So I have the associations keys, I have the configuration keys. For example, for this Lambda, we see that we got the policy that is attached to the Lambda, and some other information. We have the tags section, the account, and the CloudTrail key, and finally the impact one. Account and CloudTrail are by default disabled. So what we will do now is I will run again MetaHub, but this time I will enable all the context keys. So again, tags, config, the ones we had before, but I also add now account and CloudTrail. And this time I will filter by tags. So I will apply a filter here, tags, and I will ask for only the resources that are tagged as service equal demo. Again, we have the options here. Now we see that we have the filters that I'm applying, the context options that now include account and CloudTrail, the filters, the outputs that are all enabled. So again, MetaHub is fetching the finding from Security Hub. The same amount of findings because we didn't change the filters. This time we see in the results section that now we only have 6 findings affecting only 2 resources. This is because these are the only resources in my account that are tagged with this filter that I apply. So this time I will open the short output. We see here that we have the 2 affected resources. So let's start exploring in details what we have here. So for these resources, I have the findings. This time I open the short output. The difference between the short one and the full one is that for findings, we only see the title here, nothing else than the title. So these 2 security groups are affected by the same findings. I deploy 2 security groups with the exactly same configuration. These findings are related to open ports that we have in this security group. So let's start exploring for example, the config section. Here we have configuration from the affected resource itself. For example, its rules. We see that we have 2 rules. The first one is a port 22 TCP open to anyone, and the second one is the port 443 that is restricted to a host. We have some other configuration here. We will explore now the associations keys. We see that this security group is associated with a VPC. So we can expand this VPC key and see the configuration from the VPC that this resource is associated with. For example, the network configuration, we see that this is not the default VPC. And we once more can get the association from the associated resource. And in this case, we get the subnets. We can expand here again and get configuration from each subnet. And then we have the tags that are associated with this resource. So this is why we got the resource using these filters. Here we see the service equal demo. We have also an owner, an environment tag. Then we have information about the account, the alias, the alternate contacts. In this case, we see that this account is not part of any AWS organizations. If we are scanning resources that are actually part of an AWS organization, here we will have more details about that organization. Finally, we have the CloudTrail key. Here we have critical events related to this affected resource. For example, the creation event. We have the username, so who created this resource, the time when this was created, and also we have information about who authorized the security group ingress rule. So let's explore the second one. Almost the same configuration that we have the two rules here. But this time we see that this security group is again associated with a VPC, but this time is also associated with two network interfaces. And we see that these network interfaces are part of two different EC2 instances. So we can here expand the configuration that we are getting from the EC2 instance. And we see, for example, that this EC2 instance has a public IP, the key, the private DNS. We have the metadata option. We see here that metadata version 2 is not enabled. Then we have also other configuration. If we go to the associations, we will see the association with this instance. For example, this instance is associated with other two security groups. It's associated with IAM role, so we can expand here the configuration. And we see that this IAM role has no inline policies. We see the trust policy. So in this case, this trust policy is configured for EC2. We see once more the associations of this IAM role. And in this case, we see that this IAM role is associated with IAM policies. So we can drill down into these IAM policies once more. And we get, for example, the exactly statements that this policy is using. So we have all the statements here. And we see, for example, that this IAM role this IAM policy is also part of other IAM roles. So in a very easy way, we see that in this case, this security group is associated with an EC2 instance, and we have all the configuration of this EC2 instance to start making decisions about if these security findings are important or not for us. We'll see here that at the security group level, we also have more information here. For example, we see that this security group is attached, and this is based on the information that we have from the associations. So some keys that we have under configuration are generated based on the associations that we found from each resource. Then we have again the tags, the account, and the CloudTrail section. So let's now explore the last section, impact. I will expand these two and let's analyze the difference. So in the impact key, MetaHub is trying to calculate these important properties about each affected resource: exposure, access, encryption, status, and environment, and finally the scoring. So for the first key, for exposure, we see that in the first security group, this one was classified as unrestricted private. If we want to understand why it was classified as unrestricted private, we can expand this again, and we will see here that this is unrestricted private because we found that there is an unrestricted ingress rule, but the resource is not public. So this resource is unrestricted but private. For the following keys, we don't have information about its policy because this is a security group, so we have an unknown key here. Same for encryption, this is a security group, there's no encryption configuration. For the status, we see that this security group is not attached. How we know that it's not attached? Based on the keys that we found in the configuration. For environment, we see that this security group was classified as development. Why? Because we found a tag environment with the value development. You can configure the tags that you are using in your environments in the configuration file of MetaHub to define how MetaHub should classify your resources. Finally, based on all this information, MetaHub starts calculating a metric. In this case, the metric is 8. So this metric was generated based on the findings that are affecting this resource and the contextual information. So let's check the second one. In this case, we see that the security group was classified as effectively public, and the reason is that we found a public entry point, and we also have unrestricted rules. So we classified this as public effectively. Again, we don't have information for access, we don't have information for encryption. We know that this resource is attached based on its associations. And again, we classify this resource as development based on its tagging. So finally, MetaHub calculated a score for this resource that is almost 85%. So here we have a really easy way to understand for the same findings which one has more impact in our context. So another way of seeing this information is using the HTML report. I will open this one. So again, here more or less the same idea. We are grouping the findings affecting the same resource under the resource. We can close this or expand. We have the severity of each finding here in the second column. The third column will show us the impact. So for two findings that are the same severity, for one we classify it as low impact and the other one as high impact. And then we have the properties that we analyzed before. So exposure, access, encryption, status, and environment. All these properties, all these columns, you can filter by any of these values. This is really useful if you have a lot, many findings. You can start analyzing all these findings together, define prioritization based on these properties. We have more information here about the affected resource. All these columns, you can select the ones that you want to see and the ones that you don't want to see. And also here, for example, the name and the owner columns that we are seeing here are based on the tags that we found in our affected resources, but you can define which columns you want to see here based on your context. You can do this by modifying the configuration file of MetaHub. Also, you can export again this HTML report as in another format. You have another views here. So if you don't want to group your findings, you can see the findings as a list. So here, in a really easy way, you have a way to prioritize findings based on scoring. The last thing I want to show today is how to integrate this directly in Security Hub. So what I will do now is I will try to search for this resource in my Security Hub findings. So I will use the resource ID filter. So now we see the three findings that we are seeing here. So MetaHub lets you you can run MetaHub as a Lambda function. The code for deploying that Lambda is part of you can find it in the repository. You have a Terraform folder. This will deploy the Lambda and will also deploy a Security Hub custom action. What is a Security Hub custom action? If you select a finding, you will have an option here, MetaHub. So what I will execute this for this finding. And what this will execute is the Lambda that was deployed using that Terraform code. And the idea here is that you will execute MetaHub only for this finding. And what the Lambda will do is enriching back your findings with the information of the context and the calculations about the impact for this finding. So this could take a couple of minutes. Let's check the history. Okay, it's done. So what we see here is that MetaHub updated the finding. It added the criticality, the impact scoring as criticality for this finding, and all the information that we have about its context. So if I open this, we will see that here, I need to refresh this. This could take a couple of minutes. Sometimes the API takes some time to update the finding. But what we will see here is that we will add all these keys as part of the finding. This is useful if you want to apply filters. You can use the user-defined fields. For example, filter by exposure, and use here effectively public, and apply filters based on, well, it was not yet updated. Now I see that it's updated. You see that there's a note here from MetaHub. We executed enriching findings. So I will open this again. Now I have all the information here. So what I want to filter is by exposure. I will copy this. So I will use the filters, user-defined fields, exposure. And now we see that we can filter by information that MetaHub is adding to our resources. You can also use insights for this. So I have here the insights for the information from MetaHub. So I see here that for effectively public, now I have one resource. So yeah, these are different ways of using MetaHub. The idea of providing you a programmatic output is that you can integrate this output with any other tooling that you are using internally. For example, if you want to create an internal ticket with all the contextual information, that's possible by reading the programmatic output that MetaHub is generating. I hope you found this useful. If you have any feedback and you want to contact me or use the repository, leave an issue, leave a pull request, more than happy to connect. Thank you.